Hello and welcome to another orbital mechanics video. I'm still going through the book Orbital Mechanics by Howard D. Curtis, 4th edition, and I'm up to problem 2.25. In this video I'm going to do 2.25 to 2.28, and they're all quite straightforward, so I'm not going to go through them and write them out on paper this time. I'm just going to go through them through the book against the Matlab scripts. So let's go. 2.25 is: a satellite has perigee and apogee altitudes of 521,000 kilometers. Calculate the orbital period, eccentricity, and maximum speed. So the only interesting thing here is the maximum speed. That occurs when we are at perigee. So the problem is very simple once you know that, and we just do out the equations that we've done for previous examples, and we get the right answer here in the script. So moving on to 2.26, a satellite is launched parallel to the Earth's surface with a speed of 7.6 kilometers per second at an altitude of 500 kilometers. Calculate the period. Now this one again is just a word problem. A satellite parallel that is running parallel to the Earth's surface will be at either perigee or apogee. So we can work out the eccentricity with either assumption, and if you get the wrong one, your eccentricity will be negative. So in this case, the satellite turns out to be at apogee, and that gives an eccentricity of, a period of 1.569 hours, that's what it's asking for. So yeah, moving on to 2.27. Sorry, back there we have a slightly different answer, but that's been the case throughout this book. There's been slightly different answers, but on comparing my answer to other people's answers, this is consistent, and this looks like a calculator mistake. So just move on to 2.27. A satellite in orbit around the Earth has a speed of 8 kilometers per second at a given point of its orbit. If the period is 2 hours, what is the altitude at that point? So again, this is very simple. We've been given the period of 2 hours, so we're just rearranging some basic equations. We have the gravitational constant, radius of the Earth, the velocity, the period, and from the period we can get the semi-major axis, and then we can get the radius and the altitude. So there we go, 6.48 by 10 to the 5, 6.48 by 10 to the 5. Next question is 2.28. A satellite in polar orbit around the Earth comes within 200 kilometers of the North Pole at its point of closest approach. If the satellite passes over the pole once every 100 minutes, calculate the eccentricity of its orbit. Again, this is basically the same as the last question. We've been given the period, and we're being told that the perigee is at the North Pole, and that radius is 200 kilometers. So we can get the semi-major axis from our typical equations and then get the eccentricity. I'll just run that, and the eccentricity is 0.0783, which matches the answer here. So that's the 4 questions there. They're quite straightforward. Like I said, we've done these before in the previous questions, from like 2.17 all the way to 2.24. So if you're not sure how to do them, look at my previous videos. If you think I've made a mistake, or you have any questions, leave them in the comments below, and I'll put the MATLAB in the description. Thank you very much. Goodbye.